So that remainder theorem said that whenever I use synthetic division, I get the remainder, or whenever I plug in, I get the remainder. The factor theorem is what I was saying is going to be that next step. The factor theorem says when I get the answer of 0, remember when we plug in, this is telling me that it's the remainder. So when I get a remainder of 0, then it's a factor. And remember the word factor, whenever we had a polynomial and we had like x plus 7, we would just say, okay, well, let's set that equal to 0, and that factor will lead us to the solution. So what that means is that when I find that the remainder is 0, then I know that the linear factor was actually giving me a solution to my polynomial. Okay? So I could take that value and I could either plug it in with synthetic division, or I could plug it in by evaluating, see what the remainder is, right, using that remainder theorem. And if the remainder is 0, the factor theorem says not only do I have a factor, but that will lead me to knowing that I have a solution to my polynomial. Okay, so the whole idea is that I'm going to use the remainder theorem to get the remainder, and then use the factor theorem to say, yes, it's a solution and a factor, or no, it's not. So let's look at an example. Let's say that we had the polynomial 2x cubed minus 5x squared minus 9, and we wanted to know if x minus 3 is a factor. Okay, so with that being said, we know it's a factor with the remainder theorem if the remainder is 0. Okay, so the way that we can tell what the remainder is by either using synthetic division or plugging it in. Remember, because the remainder theorem said that if I were to take this and say, well, x is going to equal 3 here, I can either do synthetic division or I can evaluate at 3 and I'll know what the remainder is. Okay, so that was our remainder theorem. So we're going to use that remainder theorem, okay, and we're going to find out if we indeed get 0 to answer our question. So I'm going to do, let's say that we do synthetic division here. All right, so let's plug in that 3 into our box. And we're going to say 2, negative 5. I can use a 0 and then a negative 9. Remember, I use a 0 because there's nothing there. So now I'm going to bring down that 2. And I'm going to start to multiply and add. Multiply and add. Multiply and add. So now when I'm done, I'm going to look at the remainder. So the factor theorem says that since that remainder is equal to 0, then yes, it is a factor. What that also means is that not only is x minus 3 a factor, x equals 3 is a solution. Okay? So I can either use synthetic division or I can evaluate. So if I were to evaluate, I'm doing the same thing. This time I'm going to evaluate. So let's say we had f of 3. I'm going to plug in a 3. And what I'm going to notice here when I plug that 3 in, that was a weird 3. When I plug that in, I'm going to get 0 again. Same thing, because remember the remainder theorem said that I can either use synthetic division or I can evaluate, and I would get a solution if the answer is 0. Okay, now let's say instead we wanted to test another number. So let's say we want to know if x plus 1 is a factor. So again, I can either use the remainder theorem or I can evaluate. I'm just going to quickly evaluate here. So I'm going to plug in and I'm going to say, well, x plus 1 equals 0. So I'm going to be plugging in a negative 1. So I'm going to say f of negative 1. So let's see what happens when I plug in a negative 1. The question really is, am I getting a 0 as my answer? So let's see what we get. If I plug this in, so I'm going to get actually negative 16 here. So the answer to this would be that no, it is not a solution and it is not a factor because I did not get a remainder of 0. So no, since the remainder does not equal 0, then x plus 1 is not a factor, which means that x equaling negative 1 is not a solution, right? So that remainder theorem tells us that we can use synthetic division or evaluate at the value. The factor theorem then goes a step further and says, well, if that remainder that we get is actually 0, then we can say it's a factor, then we can say it's a solution.